ground fault circuit interrupter, or GFCI, is a safety device designed to protect individuals from electrical shock. It works by monitoring the current flowing into and out of a circuit. If there's an imbalance, indicating that current is leaking to ground, the GFCI trips and quickly cuts off the power. This prevents potentially fatal electrical shocks. Now, concerning 220-volt circuits and the use of a GFCI, a crucial element for proper functionality is the neutral wire. While some 220-volt circuits may appear to function with only two wires, typically two hot wires, a GFCI requires a neutral connection to operate correctly. The reason for this lies in how a GFCI detects ground faults. It compares the current in a hot conductor, or conductors, with the current returning through the neutral conductor. Under normal operating conditions, these currents should be equal. However, if a ground fault occurs, some of the current will divert to ground, creating an imbalance between the hot and neutral conductors. The GFCI senses this imbalance and trips, interrupting the circuit. Without a neutral connection, the GFCI cannot accurately monitor the current balance and therefore cannot detect ground faults effectively. In a two-wire 220-volt circuit typically used for appliances like older electric dryers or some heaters, there isn't a designated neutral wire in the traditional sense. Instead, there are two hot wires, each carrying 110 volts relative to ground, combining to provide 220 volts between them. While these circuits can function for their intended purpose, they aren't compatible with GFCI protection unless modifications are made to include a neutral wire. Attempting to install a GFCI on a two-wire 220-volt circuit without the neutral will likely result in the GFCI either not working at all or, worse, appearing to work but not providing the intended ground fault protection. This creates a false sense of security, which can be extremely dangerous. So, if you're considering adding GFCI protection to a 220-volt circuit, it's essential to ensure that the neutral wire is present and properly connected to the GFCI device. If your existing circuit doesn't have a neutral, you may need to run a new cable that includes one or consult with a qualified electrician to determine the best course of action. It's also important to note that electrical codes vary by location, and it's crucial to comply with the specific requirements in your area. A licensed electrician will be familiar with these codes and can ensure that your electrical work is done safely and correctly. In summary, while a 220-volt circuit may sometimes operate without a neutral wire for certain applications, a GFCI requires a neutral connection to function properly and provide ground fault protection. Without the neutral, the GFCI cannot accurately monitor the current balance and will not be able to detect and interrupt ground faults, leaving you vulnerable to electrical shock hazards. Always prioritize safety when working with electricity, and if you are unsure about any aspect of electrical work, consult with a qualified electrician. Remember to always de-energize the circuit before working on it, use appropriate safety gear, and double-check your connections before restoring power. Ground fault circuit interrupters are designed to protect people from dangerous electrical shocks. They work by constantly monitoring the electrical current flowing in a circuit. A GFCI will quickly trip or cut off the power if it detects an imbalance in the current, which indicates a potential ground fault. This rapid interruption prevents electricity from flowing through a person's body, thus preventing severe injury or death. When it comes to 220-volt circuits, the neutral wire plays a crucial role in the operation of a GFCI. A standard 220-volt GFCI device needs a neutral connection to function correctly. The GFCI compares the amount of current going out in the hot wires with the amount of current returning on the neutral wire. In a normal, properly functioning circuit, these two amounts of current should be identical. However, if a ground fault occurs, some of the current will leak to ground, causing an imbalance between the outgoing and returning current. It is this imbalance that the GFCI detects. When the GFCI detects this imbalance, it immediately trips the circuit, cutting off the power and preventing electrical shock. Without a neutral wire connection, the GFCI has no way to accurately measure the returning current. Therefore, it cannot detect any imbalance caused by a ground fault. The GFCI will be rendered useless and unable to protect against electrical shock. If a 220-volt circuit lacks a neutral wire, a GFCI cannot be installed and expected to work correctly. The circuit would need to be rewired to include a neutral wire before GFCI can be properly installed. Older 220-volt circuits, such as those used for older electric dryers or some heaters, often do not include a neutral wire. These circuits typically use two hot wires that supply 110 volts each, combining to provide a total 220 volts. It is important to remember that if you are considering adding GFCI protection to a 220-volt circuit, you must make sure that the circuit includes a neutral wire. If the circuit does not have a neutral wire, you will need to consult with a qualified electrician to determine the best way to add GFCI protection to the circuit. Installing a GFCI on a 220-volt circuit without a neutral wire is extremely dangerous. The GFCI may appear to function correctly, but it will not be able to protect against ground faults. This can create a false sense of security, leading to a potentially fatal electrical shock. Electrical codes in many areas require GFCI protection for certain types of circuits, especially those located in damp or wet locations. It is important to check your local electrical codes to ensure that your electrical work meets all safety requirements. A licensed electrician will be familiar with local codes and can make sure that your electrical work is done safely and up to code. Before working on any electrical circuit, always turn off the power at the breaker box. Use a voltage tester to ensure that the circuit is energized before you begin working. Wear appropriate safety gear, such as insulated gloves and safety glasses. Double-check all connections before restoring power to the circuit. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to do the work for you. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock. Ground fault circuit interrupters provide an important layer of protection against electrical shock. By constantly monitoring the current flowing in a circuit, they can quickly detect and interrupt ground faults, preventing serious injury or death. In the case of 220-volt circuits, the neutral wire is essential for the proper operation of a GFCI. Without a neutral wire, the GFCI cannot accurately measure the returning current and will not be able to protect against ground faults. When working with electricity, always prioritize safety and consult with a qualified electrician if you have any questions or concerns.